Okay. Good stuff. Things queued up. Here we go. So the fancy title for today's lesson is the present value of an annuity. Um, but the big idea is that we've saved up a bunch of money and we want to live off that money. Or we know, what kind of lifestyle we want to live when we're retired, and we want to plan for how much do we have to save up. Very relevant questions for you guys. So the motivating problem here, Owen and Anna are approaching retirement, putting their finances in order. They've worked hard, invested their earnings, and now they have a large amount of money on which to live. Hopefully, we're all at this point someday. They hire an advisor, and you guys won't need advisors because you guys will know how to use a TVM solver and can plan this stuff by yourself. But together, they consider whether Owen and Anna have enough money to allow them to live comfortably for the rest of their lives by making regular withdrawals. So regular withdrawals, we're simply meaning the same amount, the same time frame. So like the same amount every month or every 2 weeks or twice a month. Some people like to do that depending on how they were paid before they retire. To do this, they calculate what's known as the present value of an annuity, which is a fancy way of saying how much do I have to have saved up in order to make regular withdrawals for a certain amount of time. And yesterday, we did situations like this. You're not late. Don't worry about it. It's okay. Yesterday, we looked at examples where we start with nothing and then make little regular payments over time. We save a big chunk of cash. Today's problems, we'll have a big chunk of cash saved up, and we'll make regular withdrawals over time until it's all gone. So we're going to get started with an example, solve it 3 different ways like yesterday, and then just get more experience using this variety of tools. For those of you guys who come in, I think everybody should have a TVM solver on your desk. You can follow those prompts to get there. And if you can have a green check mark queued up, that would be helpful. And I will have to track them down for that eventually. This is going to make great YouTube content. All right, so we're going to start with a simple problem because, like, if we were doing a retirement scenario where, say, you were planning to, like, live off, make monthly withdrawals off of your savings for 20 years, a timeline and doing that by hand, very impractical. So we're going to do a scaled down version here. Josh is putting his summer earnings into an annuity from which he can draw living expenses while he's at university. He's saving up a big chunk of cash so he can live off that money while he's at university and not working. So he thinks he'll need to withdraw $900 per month for 8 months. We have the interest rate, how often it's compounded, and we want to know how much does he have to invest, how much does he have to have in the bank account so he can make these withdrawals. And the idea is he doesn't have to have 900 times 8. He doesn't have to have all 7,200 saved up, because while he's withdrawing that money a bit at a time, it continues to get interest and stretched out further. So a couple things we need in order to do this. Recall last week you guys learned the compound interest formula. I'm just going to put this above the timeline. We're going to be making use of this. A equals P times 1 plus I to the little n. You guys had that in your notes countless times. We used that yesterday in a timeline. We found a bunch of future values. Today, we're going to be finding a bunch of present values. So I'm going to rearrange this to our old friend P equals A times 1 plus I to the power of negative n. That was the present value formula. I believe it was last Friday that I introduced you guys to that formula. That allows you to calculate the present value for a given future value. Can I zoom in one more time here? Yeah, maybe we'll try that. Okay, one other thing we'll need in this question is little I. What's the interest rate per month? Because we know it's 6% for the whole year. So just up here, before we start, let's just do our usual little calculation. We'll take 6%, 0.06, and divide that by 12. It's a monthly problem. I think that's 0.005. We're going to do this one by hand using a timeline. You guys are going to see that it sucks and it's very impractical. And then we're going to develop 2 ways to do this, one using formula, connecting it to series, and one using the Tvm solver. So let's dive in. We're going to head to our timeline here, and I want to focus in on month number 1. At the end of that month, we take out $900. So we're asking the question, what would I have to invest now so that in 1 month I can withdraw $900? So I'm going to make a little arrow back to now. And the way we would calculate that using tools from last week is using our present value formula. It'd be the future value. And then, you know what, actually, I'm going to call an audible here for you guys. And I'm going to squeeze this in a different color. You could also write the present value formula as A divided by 1 plus I to the power of n. Same idea. I think some of you guys might find that more helpful for what we're doing. What's this thing? Oh, wait. So what do we have to invest to have $900 after 1 month? Well, it's had 1 month to grow. It's had 1 compounding period to get interest. So to calculate how much you would need to invest to get $900 in a month, it'd just be 900 divided by 1.006. And then we ask, well, how much would we have to invest now to withdraw $900 in 2 months? You do something very similar. That withdrawal would have had 2 months to get interest. So using the present value formula, it would be 900 divided by 1.006 squared. And we'll go down the line. We won't do it for all 8. We'll do it for the ones that are visible on this timeline here. The third withdrawal will have had 3 months to get interest. So its present value, 1.006, 900 divided by 1.06006 cubed. And then down the line, for completeness sake, we'll get these final 2 on there. So we've got 5 of the 8. Morning, Aaron. Where's a good spot for my handsome face? Maybe down here? Let's see. 900 divided by 1.006 to the power of 4. And finally, 900 divided by 1.006 to the power of, oh, sorry, not 4. That would be 7 because it's the 7th year, right? What we want to do to find out how much we have to invest now to make all of these $900 withdrawals, we need to find out what the total of all these present values are. So we're going to do that calculation in the space to the left here. And I'll help you guys out with that. So let's get the grand total. Move my face back over here. All right, so for the total, we have to do this. We have to do 900. Oh, why didn't you guys tell me I've been writing 0.006 the whole time? It's 0.005. You guys got to tell me this kind of stuff. Did anyone notice that? And just like, oh, well, he'll find it eventually? I don't know. Okay. Thank God we found it. Is it going to be one of those days? I hope it's not going to be one of those days. 5, 5, 5, and 5. Okay, phew. So we have 900 divided by 1.005. And then we have 900 divided by 1.005. I don't know why I have the brackets there. We don't need them if you don't want them. Squared. And then all the way down the line up to 900 divided by 1.005 to the power of 8. So this is going to be a little bit of a beefy calculation, but it's the only one we're going to do today. I'll give you guys a bit of a tip for slamming this out on your calculators. You can actually take out a 900, and then it's just doing 1 divided by 1.005 plus 1 divided by 1.005 squared, and then doing that all the way up to 1.005 to the power of 8. No way around it. It's not a nice calculation, which is why we're doing a simple problem first. But as I said, it's the last one we'll do. So I'll suffer along with you guys. Let's do it. So I can just do this all in one step on my calculator. Or you can do like 1 divided by 1.005, get your answer, and then add 1 divided by 1.005 squared. All right, I did this ahead of time this morning just to make sure. I did it now again. I got the same thing. I got $7,040.67. I mean, honestly, if you tried it or not, I don't even care. It's like the one time we're gonna do a timeline calculation. But just I just hopefully you guys are convinced you can do it by hand. And to find this present value total, you find the total of all the present values of each withdrawal. It's a little bit of an annoying method, but luckily we're going to use the tools we have to develop some faster ones. But we can kind of wrap this up. Josh must have $7,040.67 saved up. Make these 8 withdrawals of $900. Big idea is he withdraws 8 times 900. He withdraws 7,200, but he only had to invest about $7,000. So he made an extra $200 while he was living off that money. Yes. Okay. Okay, we've used a timeline. Let's look at a couple of other methods. So first, we're going to develop a formula, kind of following the same pattern as yesterday. And if you look at these 8 present values, there's a pattern there. The first one is 900 divided by 1.005. And then every term after, you're adding in another 1.005 on the bottom. So we can write this as a geometric series in this way. The value of A (900) divided by 1.005. That was the first term, that first present value. And every time we add a 1.005 to the bottom, that means R is 1 divided by 1.005. And here we had 8 deposits. Now, In my opinion, we did a full derivation yesterday. In my opinion, not crazy necessary to do a full derivation for this one. We can do it. The math is a little messier, but we can do it. However, hopefully you guys are convinced that this is a geometric series. We can use the formula, and if you use the formula and simplify these things, we get this formula for the present value of an annuity. It's this, and then you guys can just use it. It's R, which represents payment, which in this case is a withdrawal. And in square brackets, 1 minus 1 plus I to the power of negative n. Close that bracket off. All divided by little I. And now you guys just have the formula, and now you guys can just use it. Let's give it a little spin. In Josh's problem, the payment amount, 900. Little I, we already calculated that, but I'll just re-show it here. Take the yearly interest rate divided by 12 was 0.005. And the number of withdrawals, 8. So yeah, we should get the same value. I mean, we should get the same value to within a cent or two, depending on, in that first calculation, if you did any rounding. And I admittedly, I did a little bit of rounding, so I might be off by a cent here, but we'll see. I might not be. 900, 1 minus 1.005 to the power of negative 8. All divided by little I, 0.005. Should give us the same thing. Your scientific calculators should be able to handle this. You could do 1 minus 1.005 to the power of negative 8 first, then multiply by 900, then divide by 0.005. And I'm just keeping everything stored in my calculator, doing it all at once. Okay, yeah, I was a cent off with my hand calculation because of my rounding, but I actually got 7,040.66 if you round to the nearest cent. Anyone else at the same thing? I see some nods. Okay. So two methods. You can use a timeline, not very practical. You can use a formula. Formulas exist. We can represent this with a geometric series. When we want to do lots and lots of problems and make adjustments and make tweaks, we want to be using technology so we can make changes and have everything update very quickly. So here we're going to use the Tvm Solver. I believe everyone except Aaron, I'll get you one. I had a Tvm Solver on your desk. If you haven't yet, can you follow the prompts on the board and get to the Tvm Solver screen? And we'll train you guys up on how to use the Tvm Solver to solve these kinds of problems. Isn't turning on? That's not good. Pardon me, excuse me. No worries. I'm going to go through with what we'll have in the parameters, and then I'm going to make a tour of the class. And because this is the first time most of you guys are using the Inspires for this, we'll spend a few minutes where I just make a tour and make sure everybody's good. And once we just invest that few minutes up front now, for later problems, we should be able to go a lot faster. So in this case, just like yesterday, N isn't the number of years, it's the number of payments. In this case, our payments are withdrawals. So N, in this case, we already know it's 8 months. So N is 8. Josh makes 8 withdrawals. In practice, if we have the years and how often we're making withdrawals, we can do a multiplication to get that. Josh's whole interest rate was 6%. PV is what we're finding for in this case. So I'll circle it. PMT, so Josh is making withdrawals. He's getting money. So technically we should have our PMT being positive. So positive 900. And he's withdrawing all this money till it's gone. So FV is equal to 0. As usual, like yesterday, PPY and CPY should always match. He is making 12 withdrawals per year, and interest is being calculated 12 times per year. So I'd love you guys to slam those things in. When you do that, you can go to what you want to solve for, PV, and you can get PV, and it should match up what we have. So I'm going to do just a little tour, and you can flag me down if you're having any issues with your Tvm solver. Again, we'll invest the time now so things move faster in the future. Did you get the Tvm solver for you? So you go to calculate. Menu, finance is number 8. Finance solve. And then you can just tab your way through all the things, and you can change things. When you want to solve for PV, you just go to PV and press the Enter button on your calculators. It's okay, it's new. But I wanted to use these today because your cells can only handle sort of specific types of questions. Okay, on touring, you're flagging me down and need assistance. Did you get it? Oh, did it work out? Nice, perfect. Flagging me down, need assistance. You should be following up for me. Okay? So, yeah, no, but you're going to All right, so if you want help, you're going to have to say, hey, Mr. Smith, can you help? You guys get the same result? I see a few nods. Okay, we need to get a bit proficient with these because when you guys do your final performance task, your little finance case study, we're using Tvm Solver. We're going to be using these. We're not going to be using our phones for obvious reasons. So we want to get trained. We want to get good at these. So if you're having some trouble, you need to advocate for yourself. I'll come help you troubleshoot. It'll take 5 seconds. Okay? Let's move on. And on the next question, I'll tour around again and try to troubleshoot anything we saw. But yeah, I'm going to pull it up and do the same thing. So, and I mentioned this to many of you guys earlier, but the tab button on your TI Inspire is a really helpful button. It just allows you to go from field to field very quickly and easily. So 8 withdrawals, 6%, PMT 900, FV is 0. Of course, like when you're at home and practicing, the online one worked perfectly. It's just that you can't enter negatives for certain fields. And it's 12 and 12. Automatically changed it. And we solve for PV. There we go, 7,040, 66. Life is good. So my note here, 7,040. Like we had before. For the rest of the day, we're going to do a few more examples, get used to the formula, get used to the Tvm solver, get used to this new kind of problem. Let's continue. Super relevant question. Fiona has saved up $300,000 when she decides to retire. Ideally, after yesterday, you guys all have that in mind. We're saving up as we work. We get to our retirement, we have a large chunk of money saved up, but it's now time to live off of that money. And Fiona wants to plan. So she wants to stretch her money out for the next 30 years. So it's in her best interest to make a plan to make sure she withdraws what she can so she doesn't run out of money. Her money lasts that long. So we are going to do this question two ways, no timeline. We'll use the TVM solver first, and I'll show you guys how we can do it with our newly derived formula afterwards. So let's dive in here. So Fiona is making withdrawals for 30 years. And this question is saying she is making monthly withdrawals. So 30 times 12, 360. You can do that math on the side, but I believe the TVM solver will actually let you put in 30 times 12, and we'll just update that in the field for you. 6% interest. This is a different kind of question. Here, we actually know what she has saved up. She starts with 300,000, and we're going to pop that in as negative because she has had to invest that 300,000. She has given that $300,000 away temporarily. This is neat. We're solving for payment. How much can she withdraw to stretch that money for 30 years? Super, super, super relevant for everybody. FV is 0. The money will be all gone in 30 years. And 12 and 12. I'm going to come along for the ride, and then I'll do a little tour. Troubleshoot any issues. I guess I can just clear this all, can I? 360 percent minus 300,000. This is great. This is empowering for you guys. You can plan your future. FV is 0. Another monthly problem. PMT positive because she's getting that money. 1,798.65. You guys get the same thing? All right. So let me just get that down on my sheet. Already forgot the number. 1798.65. Wendell Clark 98.65. 98.65. Okay. Method 2, we're going to use a formula. Our formula, PV equals R 1 minus 1 plus I to the power of negative N divided by I. In the last question, we had R, we had I, we had N. This question, we have PV, we have I, we have N. We're finding R. In this question, we're given the PV. It's $300,000. The I we can calculate. It's actually the same as the Josh question. It's 0.06 divided by 12. So that's 0.005. And little n, we already calculated in our TVM solver screen, but I'll write it down again. We did 30 years, monthly 360. Interest is calculated 360 times. Yesterday, we did a question 2, solving for a payment. We rearranged our formula to get a new formula that can help us find the payment in these scenarios. And it's very similar to yesterday. You want to get the R by itself. You multiply up to the little I, and you divide by all the stuff in that square bracket. And we'll go right there. R equals PV times little I divided by 1 minus 1 plus I to the power of negative N. Would you guys believe when I was in high school, like 50 years ago, like we did this stuff and we just had to have these formulas memorized? I don't know. I did it because my personality was like, okay, I got to memorize them. Like, I mean, that's ridiculous. That's my little walk uphill to school both ways moment for you guys. But yeah, you guys just have that to use now. It'll if we're doing any evaluation, I will give it to you. But now you just got to use it. So while you guys are using that, I'm gonna do a quick tour. And if you didn't get this on the TVM solver, or you had an error message or something, this is your chance to flag me down. Let's fix these issues so we can go from like noob to pro to hacker on the TVM solvers. I am coming by, and you are letting me know if you had an issue with the TVM solver. Do a tour. Seems like everybody's good. Let me know if it didn't work out for you. Okay. Everybody's okay. All right. Okay. You guys are good with that. We know what the answer is, so we should get the same thing. 300,000 times 0.005 divided by 1 minus 1.005 to the power of negative 360. Can be done all at once, but for those of you guys who are doing things in multiple steps, I'll suffer along with you. If you're going to do the top and the bottom separately, keep all the accuracy just in case. The top, not necessary. It's just exactly 1,500. The bottom, 1 minus 1.005 power negative 360. 0.833958072. And if I do that division, I should get the same answer. 1798.65. Of course I got the same answer. Woohoo. This is great. So Fiona knows exactly what her lifestyle needs to be in order to stretch that money for the time that she needs. Fiona can withdraw 1,798.65 per month to make the money last for 30 years. In the next question, guys, we're just going to use the TVM solver, and maybe we'll play around with this question a little bit, have some fun. Now that Fiona knows what she has to take out to make it stretch for 30 years, what if she wanted to live a bit more lavishly? So we understand you take out more money per month, your money isn't going to last as long. Well, let's have a look here. Same parameters for this question. So interest rate is 6%. It's a monthly question, 12 and 12. You guys don't need to change any of that stuff. She still had 300,000 saved up, negative 300,000. FV is still 0, but this time we have a payment, positive 5,000, and we're looking for N. So my anticipation is a few of you guys are going to get an error message when you try this, and we have to keep in mind the signs. PV is negative because she gave that money away and invested it. Your PMT has to be positive because she's now withdrawing that money and getting it. If you get an error message, check to see that you made PV negative. I don't need this one. Okay, so 300,000. Should be minus 300,000. Minus 5,000. All gone. Monthly. 71.51. Did you guys get the same thing? Are you guys okay if we just round that to 72? 72 months? Let's just round it to 72. So we got 71.51. So it can last for 72 months. Remember, N's not years, it's number of withdrawals. It's in this case, we're making monthly withdrawals, so it can last for 72 months. Or if you divide that by 12, 6 years. Exactly 6 years. Pretty fascinating. Takes out about 1,800 per month. Money lasts for 30 years. Takes out 5,000 per month. Money lasts for 6 years. Pretty fascinating. Now, one thing we haven't done is we haven't put it all together where you save for retirement and then you withdraw that money and look at how much interest you earn overall. It's very fascinating. We're going to do that right now, guys. And we're moving out of formula mode because we're doing a lot of tweaks and stuff. We'll do these questions purely using the TVM solver. And we're kind of at this point getting into application and like the financial planning, retirement planning. We've covered the algebra, we've connected it to series, and now we're just looking at the importance of saving money. All right, so you can imagine this as you perhaps working at your full-time job once you're done your schooling or whatever. Again, for some of you guys, that might be right out of high school, doing an apprenticeship. For some of you guys, it might be a bit later on if you go to do some post-secondary. But here we have Bort, and so Bort deposits $200 every other week into his pension fund. So this is a question from yesterday, a regular deposit question. Why would Bort deposit every other week? Maybe that's when he gets paid. If you get paid every month, maybe you make monthly deposits. If you get paid bi-weekly, maybe you make bi-weekly deposits. For most people, it depends on how often they get paid. But let's say Bort does every other week into his pension fund. He gets a return of 6% compounded bi-weekly. If he retires in 30 years, how much will he have at retirement? So we can handle this. Let's dive in. So he's making for 30 years, he's doing bi-weekly deposits. You guys remember how many times a year bi-weekly is? Every other week, about 52 weeks in a year, so 26 times per year. So over the course of Bort's working career, 780 deposits of $200, investing at 6.3. For a saving question, we're assuming Bort starts with nothing. He deposits 200. We'll put in minus 200 because he's giving that away. We're solving for FV here. And this is a bi-weekly problem, 26. Remember, currently, those guys are always matching for our annuity problems. What was the interest rate? 6.3. Starts with nothing. Deposits 200. And solve for FV. I got just over 462,000. You guys did the same thing? All right. That's a nice chunk of money. Let's get that down. I will not be able to remember this entire number. 462,573.29. 573.29. Not too shabby. Or we'll have 462, 573.29 saved for retirement. And yesterday, we did these kind of questions and we looked at, well, how much does Bort deposit of his own money and then versus how much does he have now? We saw that he makes tons of interest. But the story doesn't stop there, because now when Bort retires, while he's taking out little bits of that money, it still gets interest. That 462,000 and change is going to be stretched even further. So now let's apply what we've done today. The future value in our first question now becomes the present value in our next question. Bort has saved up $462,573.29. And we want to know how much Bort could take out every 2 weeks to stretch the money for 20 more years. We're finding a payment. The interest rate is still 6.3 and it's still bi-weekly, 26 and 26. He's going to live off the money till it's all gone. And then we just have to do our usual calculation for N. This time he's stretching it for 20 years. 20 years of bi-weekly withdrawals. Believe that's 520. Once you guys get that bi-weekly withdrawal, we're going to finally compare and see how much interest Bort made over his 50 years of working and then living off of that money. That's 462, 573, what were the cents? 29.29. This is 0. Some coffee while you guys do that. All right, here I go. Solve for PMT. $1,565.62. You guys get the same thing? See some nods? Fantastic. 1565.62. 1565.62. Work and withdraw. $1,565.62 every 2 weeks. Now we get to the interesting part. Now we can make a comparison. Again, like we talked about this yesterday, but like $200 every 2 weeks, that is a lot of money. But 520 withdrawals of about $1,600 is also a lot of money. Let's compare the two. So Bort made 780 deposits of $200. Can you guys calculate how much that is? And then he made 520 withdrawals of 1565.62. When we calculate both of those things, we'll be able to make a fair comparison and see how much interest Bort has made. Standard calculator will work fine for this. 780 times 200. $156,000. A lot of money for sure. But 520 times 1565.62. So Bort put in 156,000 of his own money and was able to stretch that into $814,000 and change, 122 and 40 cents. Crazy. The difference, I might just do this to the side. I won't write those down. To get the interest, you subtract. I'll just make a little note. Subtract. How much interest is that? How much free money 156,000. Like this is like 6 or 7 years of a very decent salary, $658,000 again in change, 122.40. And none of these numbers are unrealistic. Very realistic interest rate if you're not touching the money. Very manageable amount every 2 weeks from a paycheck. And you guys can see the power of compound interest. Very cool. Anything you guys want to chat about? I want to do 2 more things with you guys just on the TVM solver, though. I just want to give you guys more experience doing a variety of problems for your own planning. So just like we did with the Fiona question, let's compare how long his money would last if he takes out a lot more than that, $5,000. So this is a question where we're solving for N. Get back to my deep purple here. And we're using the same amount saved up, 462, 573, 29. 462, 573, 29. Again, if you get an error on your TVM solver, the main problem usually is signs. So this should be negative 5,000. Money's all gone. 26 and 26. So keep in mind, in the previous setup, he made his money last for 20 years. Let's see how long his money lasts. If he makes 5, I'm going to bet it's under 5 years, but we'll see. And the great thing is, from the previous question, all you guys have to change is the 1565.62, change it to 5,000, and then re-click on N. Amazing. 104, we'll call that 105. Head back to the notes. 104.88. Did you guys get that as well before I do more stuff? Yeah? How many years is that? We got to remember this is a bi-weekly question, so that represents 105 2-week periods. If you want to get the years, you take that 105, 104.88 or whatever, divide it by 26. So I think I was right. That looks like about 4 years. 105 divided by 26. Yeah. Basically, it's like 4.04 years, just over 4 years. You got to be smart with your money when you're living off of it. It can really, as you guys can see, 20 years now is now 4. But did I hear something? Hi. Okay. No problem. The last type of question I want you guys to be able to do, this is a very, very cool kind of question. You may have heard the term before, but Bort has a big chunk of money in his bank account when he retires, and that big chunk of money gets a lot of interest. If Bort only takes out the interest, in theory, he will never run out of money. He'll always have a little bit of income, and then at the end, whenever he passes or what have you, he'll have 462,000 and change to leave to family, whatever he wants to do. So how do we do these infinite money kind of questions? Well, I'm going to show you guys. So we have 6.3. Let's put on the easy stuff, 26 and 26. He still has his 462, 573, 29. So if we want to find out how we can just live off the interest, what we do is we set PV and FV to be the same. Bort starts a period with his $462,000, and he ends the period with that same money. But be careful, you got to make it positive. Positive 462, 573, 29. I'll just make a little note here. You just match these guys up. Different signs, though. You can put whatever you want in for N. So you can just put in like 1 if you want. I'll just make a little note. Doesn't matter. We're seeing how much can he withdraw, so his bank account never changes. He's just taking out the interest. So let's see. I mean, honestly, you could leave in whatever you had from before too. I'll just change it. So we have to change this to positive 462, 573.29 and solve for PMT. This is amazing. So Bort could theoretically, like maybe he sets the record for like oldest person, like 40 more years. He can take out 1,120 and change every 2 weeks. And then no matter what, he always has that 462,000 in the bank. It's crazy. 112085. All right, we did a variety of questions on the TVM solver, connected this idea of regular withdrawals to our geometric series from our last unit. Lots of good stuff today. I'll get this downloading and posting. I'll also stop recording.